All right, 5.2, triangle congruent postulates and theorems. Objective, students will be able to use the congruent postulates and theorems to determine whether triangles are congruent. So first thing we got to do is just define some of these postulates for you. The first one is side, side, side postulate. We just call it SSS. Basically says, hey, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Now that may seem obvious, but we're not talking about any angles here. Notice we don't mention any angles. We're saying, hey, if all we know is the three sides are the same, then we know for certain that all the angles are going to be the same as well, and therefore the whole triangle is going to be congruent, every single part. CPCTC, which we learned in the last video. So that's one thing that we know is SSS. That proves triangles are congruent. Another way that we prove triangles are congruent is side angle side, or SAS. And this says if two sides and the connecting angle, so meaning if you have two sides here and the angle in between, or two sides and the angle between, of one triangle are congruent to two sides and the connecting angle of another triangle, then the two triangles are congruent. So now if all you know is these two sides and the angle in between is congruent to these two sides and the angle in between, then that's enough to say that all of the parts are congruent, that the whole triangles are congruent to each other. So see, we only need three things to prove that all the parts are congruent. SSS or SAS. And there's more, but let's just talk about these first two. In example number 1, where it says, by what postulate do we know the triangles are congruent to each other? So let's take a look at example A. What I like to do with these is I like to go through and just mark what I know. Well, I know that these two sides are congruent. And I know that these two sides are congruent. That's given. Is there anything else that I know, just from the image or any other information? Well, I know that YQ is congruent to itself. I like to mark it with an X. So that I could say that YQ is congruent to YQ, and therefore I would have side, 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 side in the same order. So we could say that these two triangles are congruent by SSS. That's kind of how it works. Give you another example here. So what do I know? Well, I know that 5 is congruent to 5, so I have a side. I know that 100 degrees is congruent to 100 degrees, so I have an angle. And then 4 is congruent to 4, so I have an S. Well, that's SAS, side angle side in the same order. So these two things are congruent by side angle side. So that's kind of how you can use these postulates to determine whether these two triangles are congruent or whether these two triangles are congruent. So I want you to take a look at this one and see if you could figure out if these two triangles are congruent and how you know it using either SSS or SAS. Go ahead and give it a try, and then I'll put the answer up there in just a second. Well, hopefully you saw that you had this side congruent to this side and this side congruent to this side. But that's only two pieces of information, so you need a third. Well, the third is this angle and this angle. These two angles are vertical angles. So we could add in that those two angles are congruent because they're vertical. And then we have SAS, SAS in the same order. And therefore the triangles have to be congruent. All right, so let's talk about using it in a proof. I kind of already talked you through the proof of this one, which is the one that we're going to do. It says example 1A. So let's just kind of write it out. If I was to write this out in a two-column proof, I'd start off with the given, which is that QP is congruent to QN, and YP is congruent to YN. And again, that's just a given. I like to change colors just so we can see each step here. Well, what else do I know? Well, I said, hey, I know that YQ is congruent to YQ. And how do I know that? Well, they're the same thing, and in geometry we could call that the reflexive property. So I'm just going to say reflexive. I'll spell it out for you guys. Reflexive, I know my handwriting sucks, property of congruence. Okay, that's how I know these two are the same. They're congruent because they're essentially the same line. So I could say YQ is congruent to YQ. Okay, well, what does that give me? Well, that gives me three sides. That's enough to say that the triangles are congruent, so I can say the triangle NYQ is congruent to triangle PYQ, and I use SSS. to make that statement because I had 3 sides congruent. You could go back through the proof and you could see that you had a side here, and a third side there. And there you have completed the proof because you have the 3 sides, therefore the triangles are congruent. You've proven what they've asked you to prove. All right, let's go on to the next page. Okay, so we got a couple other postulates or theorems here. The next one is angle side angle, and that says that if 2 angles and the connecting side, meaning you have 2 angles, the side in between those 2 angles of one triangle are congruent to 2 angles, and the connecting side of another triangle, see how everything matches, therefore the 2 triangles are congruent, which we say here. So the 2 triangles match up completely. The whole thing must match up. So that's ASA. And one more here is AAS. If 2 angles and a non-included. Now, what do I mean by non-included side? Well, let me show you what I mean. See, I have 2 angles. Non-included basically means not in between. Okay? That's what makes it different from ASA, is that the side is not in between the 2 angles. So if 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of another triangle, then the triangles are congruent. When I say corresponding, that's important because this side that's congruent to this side has to be touching the same congruent angle, right? So it's touching angle C, it's touching angle F, and those 2 angles are congruent. So that's what I mean by corresponding. It's the same, it's in the same location, I guess, is the way you could say it. Okay. So really, angle side is a kind of a spin-off of the ASA postulate. Let me show you how. We're going to do a proof for it right here. We'll use the picture above to do our proof. So the given is it just says refer to the drawing above. That means we can write everything that's marked as given information. So let's go ahead and do that first. We'll do that in blue. We could say that angle A is congruent to angle D. We could say that angle C is congruent to angle F. And finally, we could say that BC is congruent to EF. Sorry, that's gotten real messy there. And that's all given. So all I did is I just listed all the things here that are marked. So A is the D, C is the F, and BC is the EF. Okay. Well, what else do I know? Well, here's something that we learned briefly, but we learned a while ago. If this angle is congruent and this angle is congruent in a triangle, what's left in degrees must be exactly the same. Therefore, we could say that angle B has to be congruent to angle E. And I would go ahead and mark this. I'm going to mark it with like an angle and a double hash, so just so it's different than these markings here. All right, now how do I know that that's congruent? Well, there's actually a theorem for that. It's called the third angle theorem. And you don't have to write this out, but if you wanted to, you could say what the third angle theorem says. And it just says basically if you have 2 angles in a triangle congruent to 2 angles in another triangle, then the third angle must be congruent. Okay, well, now if you take a look at our picture, we have an angle, a side, and an angle, and an angle. So what started off as angle, side, is now also able to prove by ASA. So we could say the triangle ABC is congruent to triangle DEF. And it's not just by AAS now, it's by ASA. And so we've proven that AAS is really just a variation of ASA. All right, and again, if I wanted to, I could go back up here and I could mark all the things that I had, right? The C is congruent to F, that's an A. This is my side, and then here's my angles congruent, ASA. But when I name it, it's about the direction around the triangle. Something important to note here is that it gets a little confusing, whether it's like ASA or AAS or whatever. If you were confused on how to name it, the basic trick here is that you just pick one side to start with. So for example, let's start here. And if I have to skip a side and an angle, I'm going in the wrong direction. So if I started with this as an angle, and then I start going around this way, I'm skipping this side because I don't have anything marked about this side or this side. And I'm skipping an angle, and I'm skipping an angle here, and that means I went the wrong direction. When I'm using any of these three-letter postulates, I should never have to skip both a side and an angle. So I go the other way. Sure enough, I have a side this way. I have another angle, so I did it right. It's ASA. That way you don't get confused and write SAA or something like that, because if you ever have to skip a side and an angle, you're going the wrong direction. Okay, so we did the proof about AAS. Now let's use it to determine whether these three triangles are congruent. It says, by what postulate or theorem do we know the triangles are congruent to each other? And first one, what do we know? Well, 5 and 5 are definitely congruent. So I'm going to write S and S. And then these right angles have to be congruent, right? Because they're both 90 degrees. So what else do I know? Well, it looks like, once again, I have vertical angles here, right? And so I have another A and another A. So if I wanted to name this, again, I could start anywhere I want. Let's say I started here. I don't know anything about this angle, don't know anything about this side. Then I have an angle, side angle, so that was good. If I start in the same spot, angle, and I go this way now, I'd have to skip a side and an angle, so it wouldn't work. So I got to go the other way. Angle, side, angle. So these things are congruent by ASA. All right, let's take a look at this one. Well, I know that I have an angle and an angle, an angle and an angle, so I can mark that. Angle, 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 angle. But do I have anything else? Well, sure, these things share this side here, right? So I could say side, side. I could even mark that it's congruent to itself. I like to mark it with a little X. And so I could say, well, this, I could go angle, angle, side, angle, angle, side. Again, if I started here and I wanted to go this way, I'd have to skip a side and an angle to get to S and then get to A. So naming this ASA would be wrong because I'd have to skip a side and an angle in the naming of it. So I could tell that these two triangles are congruent by ASA. All right, last one. I want you guys to try on your own. Again, feel free to pause the video, give it a shot, and then unpause it when you're ready to see the answer. Okay, so right away you might notice that, hey, you have an angle, side, angle, angle, side, angle, so this is ASA, and that's true. That will work. But remember, you also have a third angle and a third angle, so let's mark this, the double hash. So you have another angle here, another angle here. So you could also go angle, angle, side, angle, angle, side, or angle, angle, side, angle, angle, side. There's lots of different ways to do it. So this one also could be angle, angle, side. So either one works, but probably the best and easiest answer for this last one is just ASA. All right, so we've done 4. Okay, make a little note of them off on the side. We've talked about SSS, talked about SAS, then we talked about ASA, and now we just talked about AAS. So we got 4. There's a 5th one. In order to know the 5th one, we have to understand something about right triangles. So a couple key words here, probably some terms you already know. When you have a right triangle, the hypotenuse, this is the longest side of a right triangle, and the leg, this is the other two sides of a right triangle. So these are both considered legs, even though they're not the same length, they're just legs. This is hypotenuse, okay? So the 5th theorem, this is the HL theorem, and it says if the hypotenuse, I'm just going to write HYP, and a leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then the triangles are congruent. So in order for HL to work, though, it has to be a right triangle. That's crucial. It has to be a right triangle, otherwise it doesn't work. So you have to have a right angle in there. Okay, so these are your 5 these first three are postulates, the last two are theorems. That's not really that important, but these are your 5 postulates or theorems that prove triangles are congruent, or your 5 ways to prove triangles congruent. Let's go to the last example, number 3, which is on the next page. And we're going to prove triangles congruent using the HL theorem, so I'll show you how to do that. It says write a 2-column proof. The given is that angles ABC and DCB are right angles. So we can just write in the first step here, given. Okay. The next step says, hey, triangle ABC and DCB are therefore right angles, or right triangles, I mean. Yeah, sure, that's a right triangle and that's a right triangle. Well, how do I know that? Well, they're right triangles because they have right angles in them. And so that's just simply the definition of a right triangle. Okay, so we got that they're right triangles. Check. Remember, to do HL, we need 3 things. We need to first know that it's a right triangle. We need to get that the hypotenuses are congruent. And we need to at least have one pair of legs that are congruent to the other triangle. So we've got part 1. Next statement says that AC is congruent to DB. Well, how do I know that? Well, that's in my given information right here. So again, even though it's not the first step, I could just write given. And if we look at the drawing, AC and DB, AC is here, DB is here. AC is the hypotenuse of this triangle, and DB is the hypotenuse of this triangle. So we have the hypotenuses. So maybe we just want to put a little H and a check mark. Now this is not really important. You don't have to write this here. I'm just kind of showing you the logical process here. I first said they're right triangles. I then said the hypotenuses are congruent. So the last thing I need is to prove that the legs are congruent, which they said here for me. And they say that BC is congruent to CB. Let's take a look at that. How do I know that BC is the same thing as CB? Well, aren't they really just the same thing? We just wrote them in a different order. They are, right? It's the same segment. So when we flip the order, we tend to call that the symmetric property of congruence. This one and the reflexive property, those are both on that bank postulates, theorems, and properties bank I gave you. They're there. Take a look at them if you want to learn more about them, but they're there. And so these are both legs of the triangle, and so now I have that a leg from each triangle is congruent, so I have all the things I need to say that the 2 triangles are congruent by the HL theorem. Okay. I know it's a little bit much right now, but I think you guys will catch on pretty quickly here. So we've named 5 ways to prove triangles are congruent. I want you to name those 5. Why is there no AAA or SSA theorem? Answer it in complete sentences. Use drawings if it helps your explanation. I think this one you guys will be able to understand why that doesn't prove triangles congruent, but you could, so give me your best shot at that. This one may be a little bit harder, but see if you can think of a counterexample. See if you can think of 2 triangles where it has side-side angle congruence, but the triangles themselves are different. So see if you can do that, or maybe the same idea here. See if you could draw 2 triangles that have all 3 angles the same, but the triangles themselves are different somehow. All right. Thanks for watching. See you guys on the next video.